Hi guys, I am going to do the review that's on formative for chapter 10. It's in 4 sections, so I'll do the videos in 4 sections. So the first set wants us to give the best name for these things. So number 1 is PK. Let's take a look. P to K goes from the center, touches the outside edge. That's a radius. Number 2, NM. From N to M, we're touching the outsides of the circle on both endpoints. It does not go through the center, so this is just a chord. JL, the whole line appears to be going and touching the circle at only one point. That makes it a tangent. KN, from K to N, that's a line. It's a chord, but it's a chord that goes through the center, making it a diameter. And then NL, from N to L. Okay, now we're a line that's going through the circle, touching at 2 points. It's called a secant. And PN, from P to N, again, we're going from the center to the edge of the circle. That's a radius again. Is this tangent internal or external? Internal means it runs in between the circles. And external means it runs on the outside of the circles. So, cool. Number 9. We've got a party hat situation, guys. This is a tangent on this side and a tangent on this side. Both the tangents meet at a common point outside the circle. That makes it a party hat. It makes both sides have to be congruent. So 9a minus 30 must equal 3a. And then I can solve this by subtracting 9a. I get negative 30 equals negative 6a. Then I divide the negative 6. And a equals 5. Find the value of the variable. So that's what they wanted. They wanted a. A is 5. On this problem, if z is a point of tangency, well, WZ is a radius. And a radius and a tangent line always make a right angle. That's the key. So if this is a tangent, then that's a 90-degree angle, which means that this is a right triangle, which means our good old buddy, the Pythagorean theorem, is at play. C squared equals a squared plus b squared. I still want you guys to identify the hypotenuse. So across the right angle, look how confusing this triangle looks. Across the right angle, we've got our hypotenuse. And it's 3 plus r. So 3 plus r squared equals, and then the 9 and the r, 9 squared plus r squared. Now 3 plus r squared is not 9 plus r squared. It's not, okay? We must do 3 plus r times 3 plus r. And then 9 squared is 81 plus r squared. And here we've got to distribute. We got to take 3 times 3 and 3 times r. And then we got to do r times 3 and r times r. Or you can do FOIL, first, outer, inner, last. They're both identical. They're the exact same thing. So 3 times 3 is 9. Plus 3 times r, 3r. Plus r times 3, 3r. Plus r times r squared. And then this equals 81 plus r squared. There we go. And now, luckily, we can subtract the r squareds. And they cancel out. We can combine our like terms here. 3r plus 3r is 6r. It's getting a little crowded, so let me just copy down what I have left. The 9 is still there. The 81 is still there. And then now I can subtract the 9. So this is going to be 72 is 6r. Then divide the 6. So r is equal to 12. Cool. Cool beans. Okay, let's go now here. Tell whether AB is tangent to circle C. So here's AB. I want to know if it's tangent. Well, let's assume for a second that it is. If AB is tangent, and here CB is a radius, that would make this a right angle. Okay, now we're not 100% sure. We're checking to see, is that a right angle? So here's how we can check. First off, see how they put that 10 very specifically on the top, not in the middle and not labeled. So that means that the radius is 10, which means we've also got 10 down here, all right? We've got ourselves a right triangle, possibly. We've got a triangle that we have to test to see if it's right, where this side is 48, that side is 52, and then this side here is 10 plus 10, so this is 20. So if this is right, then our good old pal Pythagorean theorem should work. So let's see. The longest side is that 52. And this is a question mark. We're not sure. So 52 squared. And then here we have 20 squared plus 48 squared. And I am not going to do this in my head. Let's dig up my calculator. Okay. 52 squared. 2704. Okay, I didn't really want that to be red. And then we have 20 squared is 400. And then we have 48 squared is 3364. And then 3364 plus 400 doesn't look very promising, guys. It's a 3764, which does not equal our 2704. Wait a minute, that doesn't make any sense. Oh, I made a mistake. Over here, 48 squared, that's wrong. 48 squared is 2304. Oh, this is gonna happen again, no. Okay. So I'm gonna recopy this step. So this was 2704. And we're not sure what's happening. Oh my God, this is gonna kill me now. And then this is 400. Oh no. Plus 48 squared is 2304. This is messed up. Shoot. So guys, I really don't know what to do to make this work. 400. No, this is just gonna keep connecting lines and messing up what I'm writing. We are only one problem left to go. If I only hadn't made that silly mistake. Okay. Let's go old-fashioned way, all right? I had 52 squared. And I wanted to know what's going on with 20 squared and 48 squared. So 52 squared was 2704. And 20 squared is 400. And then 48 squared was 2304. So it actually is promising because 400 plus 2304 is 2704, and that does equal this 2704. So the Pythagorean theorem works, which means this is a right triangle. So if it's a right triangle, then AB is tangent. So is AB tangent? Yes, it is. Explain why. Because we, using the Pythagorean theorem, proved that angle B is a right angle. Okay, that's it for this one. Catch me on the next one.